Well, hello again. This is Joe from My Repair Electronics, and today I'm going to show you what I've been doing with this Samsung television. Very thin one. Let's go straight to the model number before we go anywhere else. Focus. And here is the model number. UN40C6300 SF. So, and as I've so graciously done, I'm going to spare you the boring details of unscrewing it and get right to the meat of the matter. If the darn cover plate will come off. Alright. So here we have, it's missing a board on the side, and that's not how I got it. I took it off, and I will explain why missing the input board in a moment. This is the power supply board, and that's the original one, and that's one that the customer bought, the customer being the person who gave this to me. He said to keep it. So anyway, so he bought that board, and it's not exactly the same as this board, which came with the set. Bought that other board as a replacement to try and fix the problem. Problem was the monitor was just clicking. When you hit the power button, it would just click, 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 click. And apparently this is a common problem with this model set. So I did the usual stuff, going on to various boards on the internet and coming up with the same conclusions, is that some people would replace the power board and it wouldn't fix it. And a lot of head scratching going on out there. So first place to look at, of course, is where the power comes out, which in this case is this cable header right here, which I'll show you when we get to the lab downstairs. There's a series of voltages that are supposed to show up, and you can see them. See the header here, the voltage chart. If I can focus in on it, bear with me. Okay, so that's about as good as we get. So there's the voltage chart. You'll see there's some 12 volt, and it looks like I'm looking at this upside down too. Hold on. Sorry about that, folks. Yeah, so there's some 12 volts and some 5 volts. In particular, I want to point to the 5 volt rail here because when I measured it, I tricked on the board, disconnected it from being connected to everything else and turned it on. And that 5 volt rail was not 5 volts, it was 3.6, which I thought was interesting. So after a little fussing around and probing and prodding, it turned out that it was this little MOSFET that was giving me a 3.6 volt output. In the process, there was a SMD Zener, 5.3 volt Zener right here, which I've subbed in a regular glass body Zener because I, of course, sneezed and blew the the part away after I had disconnected it from the board. SMDs, they're lovely, aren't they? So anyway, replaced it with that, and finally got the new MOSFET in there. Tricked on the board again, and got my 5 volts back. But alas, will not fire up the TV. And I'm about to go to the shop downstairs, and we're going to explore a little more into the schematic of this thing and find out why. All right, so here we are in the shop, and let's see if we can get some zooming in going on here for starters. All right, and over here is where I want to draw our attention, and that's max zoom right there. That's fine. So let's see. First things first. Let's go over here. The number of this board is upside down. So I shall rotate it so we can see. Okay. BN4403366G. And underneath here are yet other numbers that are upside down again. And they are BN41-01438B. So here's this situation in a nutshell. We've got our voltages coming in here from the power supply. When you connect it to here, the power supply, she goes clicky, 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 clicky. Why? Okay. Short and curlies of it is this 5 volts. This is for running a standby circuitry for the whole board. So any little things that are going to either be memorized or in a standby situation, such as the power control, then you need to have something to run in here and do that job. So some of the circuitry, it has to be kept alive. So that's what this 5 volts is for. And that's why when you just hook up the connector to this, it was going clicky clicky. So, all right. Why was it going clicky clicky? Well, because the 5 volts, when you connect the 5 volts, and here's a tap off from the 5 volts off of the header, and here's ground. 5 volts, ground. And what do you suppose happened when I connected this to this with an ohm meter? If you haven't guessed by now, well, it was reading 0 ohms, going straight to ground. So that 5 volts there should never go straight to ground. Never. So that's what was happening. And we're still not completely fixed yet. I've not gotten that far, but I think this is going to take care of the situation. So anyway, let's take a closer look. So this being the case, it's going straight to ground. What you normally do is say, okay, well, here's my 5 volts, and start looking around and looking for where this thing ends up. Well, here's the problem with that. I do not have schematic, and neither does the entire internet, or at least the regions I've been looking in. And that's a problem, because how the hell am I going to find it? This here does not flow out from here. It basically ends right here, where this big silver pad is. And even though it looks as though there's a couple wires running into it, they're not. I'll see if I can supply a real close-up image of this area later and pop it in here while I'm jibber-jabbering. But for right now, I'm shooting video. Anyway, yeah, so this thing just kind of ends right here. So not having a schematic and not being able to follow the traces as to where they go, what the hell are you supposed to do? Well, I've known about this trick for a long time. I don't like doing it, but had no choice. And so, some of you may have seen Louis Rossmann do this quite often. And as long as you're careful about it, it can reveal the problem. And that is to simply take a power source, a DC power supply, hook it up from here to ground, right? And you're going to pump in 5 volts, but you got to limit the current. So you got to play, if you use a current limiting power supply, just adjust it down to about 1 amp and hook it up. Or if you don't have a current limiting power supply, just play around with a few resistors. 1K would be a good place to start. Maybe lower if you need to. It kind of depends on the output of your power supply, how much current your power supply can put out. And that all depends. So just play around by shorting out the leads together through your resistor and see at what point do you get about 1 amp's worth of current. Just jump your after the resistor, of course, connect your meter up to it, like such as, wow, zooming in too close on the fluke, such as a fluke, like so, and set it to amperage, like so, or not microamps, but yeah, just regular amps. So milliamps to amps, and plug in here or here. This goes up to 10 amps. Yeah, so do that. Choose the proper amperage scale, whether or not it's milliamps or just regular amps. You have to choose that with the buttons. And so tie it in after the resistor, and you'll see on the scale, it'll show you at what point do you get 1 amp's worth of current flowing through the resistor. Okay. And that's important because you don't want to fry the circuitry that's out there. You don't want to send too much current into it. And you also don't want to go over the recommended voltage, which, of course, in this situation is 5 volts. So you simply hook in and get your power supply set. You know your current. You get it hooked into these 2 spots. This guy here. One side being ground, the other side being hot after the resistor that you've chosen necessary for the application, and let it flow. And then I've already done this, so if you haven't figured this out by now, otherwise I would be demonstrating it for you. And I did find some curious things. So now this is a big board and there's a lot going on here. So it's like, well, what the heck, man? Where am I going to find this? So one thing that Louis likes to do is take alcohol and spray it liberally, or dunk it in. You can use a little spritzer like this to just kind of spray the board and see what evaporates real quickly. That's one way of doing it. Or if you want to do a more brute force attack, which just simply start feeling around. And that's what I ended up having to do, because I would spray the alcohol on there, and it didn't really show up. Didn't reveal to me what was evaporating quickly. Everything seemed to be evaporating off at the same rate. There was no particular component getting extremely hot. Until I started poking around with my hands and found this little SMD device over here, this little voltage regulator, and the capacitor right next to it was blazing hot. At first I thought it was the regulator itself. After poking around and singeing my fingers a few times, it turned out to be the capacitor, C273 right there. Linear regulator. And so it takes, guess what? 5 volts in and 3.3 out. Now, there's 3 legs on this device. There's an input, a ground, and an output. The output is right there, next to the capacitors. The input is right there on the tab, and the ground is on the other side of the caps on that leg right here. Okay, I lifted the legs, and that didn't take care of it. It was still 0 ohms. Scratching my head for a little bit. So I figured, well, here's these little capacitors right here. This slightly larger footprint is 10 microfarads at, I think it was 10 volts, probably rated for 10 volts. What I got is a 16 volt I'm going to put in there. And this is a 0.1 microfarad. And I took that out just because I wanted to make sure I cleared out the short. Now there's 2 of these in the circuit, actually. So here's the bad component, and if I were to measure across that, it would short out and read 0 ohms. So that's off to the upper right hand side here, and the other one is a little, let me pull back a little bit, so we fall down over here in the middle, right in here. It's the same thing. It's the same IC and the same components, 10 microfarad and the 0.1. So I think on this one, when I measured it, it actually it was okay. It was, once I had taken the other ones out, this was reading okay. So that's how I was able to get a known good value off of the other components. Since it's the same type of regulator, so they got the same circuitry going on in here. So take a chance. 10 microfarads. It's going to go back in there, and I will replace the other one, the other 0.1 on the other circuit, and I'm of course going to replace the regulator, and that's going to be that. So why am I replacing the regulator? Well, remember it was 0 ohms. Well, I don't know. You're kind of taking a chance when you go running power through something that's got 0 ohms. And even though the actual device, which was the little capacitor, which was actually shorted, that it was this little 10 microfarad cap that was shorted out. Not so sure about the here. I managed to pull the legs off of this one without too much effort, so it could have gotten cooked inside. And so that's kind of why I don't like doing that method of diagnosing. But if you got nothing else to do, there's no way of checking where your voltage rails run to, then you have to resort to some brutal techniques. That's it. Anyway, we're going to change that out and I'll get back to you on this. So, yeah, I'm pretty excited that this should indeed, after changing this guy, should take care of this. Well, actually changing both of them. And change both this one and the one over here. There's only two of these LM1117s on the whole circuit board. So, and they both, obviously they both supply 3.3 volts. Probably, this one is probably operating whatever this IC does, and the other one is for everything else that's tied into it, wherever that happens to go. Again, very much a single-ended situation where, in terms of the where everything goes, on the output, the on the top here is the output. Actually, yeah, that's the output. This is the input, and then this is the ground. Then, so yeah, our 3.3 volt output is it just ends right here. There's that tiny little island here, and the rest of it is sandwiched in between the circuit board and going out to wherever the hell it goes to. So again, a schematic would have been nice, but couldn't find one. So again, the reason for doing this brute force attack. Anyway, I'm jabbering on. So let's get down to actually changing it out. Okay, then. So we're going to go ahead and extricate this whole problematic IC right on out of here. And yes, I'm using the UWU SMD device to do it. Hey, if anyone wants to kick in for one of those smart desoldering stations, or the quick, right? Smart and quick and smart. If someone wants to donate one, I'll be more than happy to take it. But hey, that did the trick too, right there. Look at that. Right on out of here. So that's one. Toss this off to the side here. And there's another one that needs to come off. And that is conveniently out of frame. Here we are. Alright, that's this guy right here. So, yeah. Let's see if I can do this without getting too much obscuring the camera view. There's a hell of a shadow there, isn't there? Let's get a little more light on the situation. That's not so bad. Alright. Get it nice and hot. I'm cranked up to 430 centigrade on this here UWU. And there we go. Nice and hot, and comes right off. So that wasn't too bad. Let's turn this off. Back at its cradle. Alright, so now that the noise of the rework is out of here, some of you may recognize the familiar silver bag in the label. It is definitely from DigiKey. And this is my replacement, LM1117 IDTX 3.3 volts. And I highly recommend ordering from DigiKey. They are absolutely the greatest. They give you this nice little moisture meter, a pack of silica gel, and of course the regulators are on a cut off from a reel. And this is also static protective. So is the bag, for that matter. DigiKey or Mauser, both very similar. Great quality, great places to order your parts from. Got these in about 2 to 3 days, and that was with regular mail. I'm on the East Coast, and they're out in the middle of the country someplace, and managed to get here right quick. So yeah, they're definitely worth it. Okay, so prior to installing the new component, we're going to just clean off this area a little bit with my Metcal solder and iron. In case you're curious, that's the brand I use and the tips I use. And it would help if it were turned on, actually. I have the other 2 tips in here, and the other one was on. So this ought to get hot right quick. And yeah, we're pretty much there right now. Yep. So this is Chemtronics wick. Has rosin in it, and definitely the thing to use for extricating any solder that needs to be taken off. Look at all that smoke. Beautiful thing. So let's just make it nice and flat, and it's ready for a new component. At this point, this is where I switch from using this big ugly 900-degree head to something a little more finesse to it. Switch over and do a tip like this, which is also quite hot, but less mass, so don't really have to worry about it killing anything. Let me get this positioned in there, Bryce. The situation. So that's in there good. I'm going to move up on this a little bit. Yeah, that's fine. A little crooked. Never hurt anybody. Get the other pin. And we're going to snake some under here. Yeah. Yeah, this is where a little more massive heat might actually come into play. Let's get the other tip Basically, you just need it to connect to the circuit and get underneath there. If I can lift it up, then I'll know it didn't get underneath. Well, let's try again, shall we? All that worrying for nothing. There's plenty of solder underneath there. So we'll try a little different technique. We'll just heat this up, get liquefaction. Push down. And that's on there. So now we know that the back of it is good and soldered up. Alright, so then the next item is the 10 microfarad cap. So this is a tiny little bugger of a cap. And there it is. Alright. See if we can zap this on in there. Ooh, look at that. Oh, nope, not quite holding yet. Zap off a little hunk of solder here. Yeah, that wasn't on there at all. Let's see if we can get the other side. And you're probably saying, what the fuck is he doing without using any flux? Well, hey, you deal with what you got. Sometimes you ain't got much. It's not the prettiest component placement ever, but it does the job. It's in there. So onwards and upwards. Let's check things out. Okay, well, the moment of truth has come. We have replaced the main power board and the input board, which is where I suspect all the problems were. So we've got the no shorts any more coming out on the 5-volt line here to here. So we're ready to plug it in. Let's see if we let any smoking pixies come out or not. I hear one click. That's good. Whoa! Magic noise of Samsung turning on. And look at that. You see that? Woohoo! Lot B. Okay, those are reflections there, those dancing ants. So, next step, let's try inputting a signal. And I gotta find a long HDMI to plug in and see what happens. Alright, so we got a movie. I'm not gonna play it for too long, but yeah, it works. And there's even audio. Nice. So it sounds good, it looks good, and a couple other inputs I can check. You know, like component. TV works.
This is it.
Woohoo!
Get ready.
Oh, a beauty contest. How about that? Nice.
From Africa and Asia Pacific is Australia.
As you can see, it looks good. You know, it's a little overblown on the iPhone here, but yeah, it looks in person. It looks good, not as contrast. There should be another repair well done.
20 semifinalists. Tonight we began with the record number 94 Miss Universe contestants. After a tough preliminary competition, the most determined competitors stood out from the pack, and our selection committee chose 20 outstanding semifinalists. Let's meet them once again. Now, this year we've added an all.
Well, I don't know about you, but I like what I'm seeing. So, again, thank you for watching, and we'll catch you again next time.
From our top 20, and then the selection committee will